Space, the final frontier. It's a place of breathtaking beauty, filled with swirling galaxies, twinkling stars, and mysterious planets. But it's also a deadly trap for humans. Venturing out without protection means facing a swift and silent killer. We're used to the air around us, but it's easy to forget its importance. In space, there's no air to breathe, no pressure to keep our bodies intact. It's a vacuum, waiting to snuff out human life in an instant. Imagine stepping out of a spaceship without a spacesuit. What would happen? The answer is as terrifying as it is fascinating. From the lack of breathable air to extreme temperatures and deadly radiation, space offers a multitude of ways to die. Let's explore the science behind these dangers and understand why venturing into the cosmos demands our utmost respect. The most immediate danger of space is the lack of air. We need oxygen to survive, and space has none. Our atmosphere, a delicate blanket of gases, provides the air we breathe and regulates pressure. In the vacuum of space, there's no air pressure to push inward. On Earth, this pressure keeps our bodies balanced. Without it, our lungs would struggle to function, and our blood would literally boil. Think of opening a can of soda. The pressure inside keeps the fizz dissolved. Once you open the can, the pressure releases, and the gas bubbles out. That's similar to what would happen to our bodies in space. Without a spacesuit providing a constant supply of oxygen and pressure, a human exposed to the vacuum of space would suffocate in seconds. It's a stark reminder that as much as we strive to explore the cosmos, we're ultimately bound to our own planet and its life-giving atmosphere. Here on Earth, we experience a range of temperatures from the scorching heat of deserts to the freezing cold of the Arctic. But space takes temperature extremes to a whole new level. In direct sunlight, temperatures can soar to 250 degrees Fahrenheit, hot enough to bake cookies in an instant. But in the shadows, temperatures plummet to minus 250 degrees Fahrenheit, cold enough to freeze almost anything solid. Imagine a pizza fresh out of the oven. That's the kind of heat we're talking about in direct sunlight. Now think about dipping that same pizza into liquid nitrogen. That's how cold it gets in the shadows. These extreme temperatures aren't just uncomfortable, they're deadly. Exposure to such intense heat or cold would result in rapid burns or frostbite, quickly leading to death. It's a reminder that space is a harsh and unforgiving environment, where even the most basic elements like temperature can be lethal. We're all familiar with the sun's warmth, but it also emits something else: radiation. Here on Earth, our atmosphere acts like a shield, protecting us from the most harmful radiation. But in space, there's no such protection. Space is filled with invisible rays that can damage our cells and DNA. Think of it like getting a sunburn, but 1,000 times worse. This radiation can cause cancer, damage organs, and even lead to death. Imagine standing in front of a microwave oven while it's running. You can't see the microwaves, but you know they're there and you know they're dangerous. Space radiation is similar, invisible, but deadly. Astronauts aboard the International Space Station experience higher levels of radiation than we do on Earth. That's why space missions are carefully planned to minimize exposure. Deep space travel, like a mission to Mars, would expose astronauts to even higher levels of radiation, posing a significant challenge for future exploration. Section 5. Tiny bullets, cosmic cannonballs. Space may seem empty, but it's actually filled with tiny pieces of rock and metal called micrometeoroids and space debris. These objects travel at incredible speeds, making them incredibly dangerous. A micrometeoroid might be as small as a grain of sand, but at high speeds it can punch a hole through metal. Space debris left over from old satellites and rockets can be much larger and even more destructive. Imagine driving down the highway and a tiny pebble hits your windshield. Now imagine that pebble traveling thousands of miles per hour. That's the kind of danger micrometeoroids and space debris pose to spacecraft and astronauts. These tiny projectiles can damage equipment, puncture spacesuits, and even pose a deadly threat to astronauts on spacewalks. It's a constant reminder that even the smallest objects can become deadly weapons in the vastness of space. Section 6. Your blood, now boiling and freezing. We've talked about the lack of air pressure in space, but its effects on the human body are even more gruesome than you might imagine. The vacuum of space is an unforgiving environment, and without the protection of a spacesuit, the human body would undergo some truly terrifying changes. Without air pressure, liquids boil at much lower temperatures. This is a fundamental principle of physics that has dramatic implications for our bodies, and guess what? Our bodies are mostly liquid. Blood, plasma, and other bodily fluids make up a significant portion of our mass. Exposed to the vacuum of space, the water in our blood would start to boil. This isn't just a theoretical concept, it's a reality that astronauts must be acutely aware of. But here's the strange part, it would also freeze. The absence of atmospheric pressure causes this dual phenomenon. That's because in a vacuum, liquids can exist in both liquid and vapor states simultaneously. This is known as the triple point, where a substance can coexist in three phases: solid, liquid, and gas. Imagine putting a pot of water on the stove and watching it boil away. The bubbles rise, the water turns to steam, and it all seems quite normal. Now imagine that same pot of water instantly freezing solid. It's a bizarre and almost magical transformation, but in space, it's a deadly reality. That's the kind of strange and deadly phenomenon that can happen in space. The vacuum environment is not just cold and empty, it's a place where the rules of physics play out in extreme ways. The vacuum of space would cause our blood to boil and freeze, our tissues to expand, and our bodies to swell to twice their normal size. This is due to the lack of external pressure to counteract the internal pressure of our bodily fluids. It's a horrifying thought, but it's a stark reminder of the extreme conditions that exist beyond our planet. Space is a beautiful yet perilous frontier, and understanding these dangers is crucial for the safety of those who venture beyond Earth. Section 7. The irresistible pull of black holes. Black holes are some of the most fascinating and terrifying objects in the universe. These enigmatic entities have captured the imagination of scientists and the public alike, inspiring countless theories and stories. They're regions of space-time where gravity is so strong that nothing, not even light, can escape. This boundary, known as the event horizon, marks the point of no return. But what would happen if you got too close to a black hole? The journey towards one is as perilous as it is intriguing. As you approach a black hole, the gravitational pull on your body would become incredibly strong. The closer you get, the more intense this pull becomes, creating a dramatic gradient in gravitational force. But here's the catch. The pull would be stronger on your feet than your head. This difference in gravitational force is due to the immense tidal forces at play. This difference in gravitational force, called tidal force, would stretch your body out in a process known as spaghettification. The term might sound whimsical, but the reality is anything but. Imagine stretching a piece of chewing gum. As you pull it apart, it becomes longer and thinner. This is a simple analogy to help visualize the concept. As you pull it apart, it becomes longer and thinner. This stretching effect is similar to what would happen to your body near a black hole. That's essentially what would happen to your body near a black hole, except on a much more extreme scale. The forces involved are so powerful that they would elongate your body to an unimaginable extent. You'd be stretched out like spaghetti, ripped apart by the incredible gravitational forces. This process would continue until your body is nothing more than a stream of atoms spiraling into the black hole. It's a bizarre and terrifying way to go, but it's a testament to the mind-boggling power of these cosmic monsters. Black holes remain one of the most mysterious and awe-inspiring phenomena in the universe, challenging our understanding of physics and the nature of reality itself. Section 8. A universe of wonder and danger. Space is a place of incredible beauty and wonder, a vast expanse that stretches beyond our imagination. The twinkling stars, the vibrant colors of nebulae, and the majestic spiral of the Milky Way galaxy all paint a picture of a universe that is both awe-inspiring and humbling. But it's also a deadly trap for the unprepared. The serene beauty of space hides countless dangers that can turn a dream into a nightmare in an instant. From the vacuum of space, which can suck the life out of an unprotected astronaut, to extreme temperatures that can freeze or boil in seconds, radiation that can penetrate and destroy cells, and micrometeoroids that can pierce through the toughest materials, and the gravitational pull of black holes, which can stretch and compress anything that comes too close. The cosmos offers a multitude of ways to die. Each of these hazards is a reminder of how hostile and unforgiving space can be. Despite the dangers, the human spirit of exploration persists. Our curiosity and desire to understand the unknown drive us to push the boundaries of what is possible. We send probes to distant planets, seeking to uncover their secrets and learn more about our own place in the universe. We launch telescopes to peer into the depths of the universe, capturing images of galaxies billions of light years away and studying the formation of stars and planets. and we dream of one day colonizing other worlds, envisioning a future where humanity can thrive beyond Earth. But as we venture further into the cosmos, we must remember that space is unforgiving. Every step we take into the unknown is fraught with peril. It's a realm where the laws of physics reign supreme, and the slightest mistake can be fatal. The harsh environment of space does not forgive errors, and even the most advanced technology can fail. It's a realm where the laws of physics reign supreme, and the slightest mistake can be fatal. The harsh environment of space does not forgive errors, and even the most advanced technology can fail. The slightest miscalculation or oversight can lead to disaster, reminding us of the importance of precision and caution in our endeavors. As we explore the universe, let's do so with a healthy dose of respect for the dangers that await us. Our journey into space is not just a quest for knowledge, but a testament to our resilience and determination. Let's marvel at the beauty of space while acknowledging its deadly embrace. The cosmos is a place of wonder, but it demands our respect and caution. Let's marvel at the beauty of space while acknowledging its deadly embrace. The cosmos is a place of wonder, but it demands our respect and caution. And let's continue to push the boundaries of human knowledge, always striving to understand the universe and our place within it. Our quest for knowledge is a journey that will never end, as each discovery leads to new questions and new horizons to explore. And let's continue to push the boundaries of human knowledge, always striving to understand the universe and our place within it. Our quest for knowledge is a journey that will never end, as each discovery leads to new questions and new horizons to explore. The universe is vast and full of mysteries, and our exploration of it is a testament to the indomitable human spirit. Let's embrace the wonder and the danger, and continue our journey into the unknown.